This is chapter 9 and we are going to learn about database design. So basically, a database is a fact or data repository that serves as an information system. If the database is designed poorly, one can hardly expect that the data or information transformation will be successful, nor is it reasonable to expect efficient and capable management of data and information. So database design provides efficiency mm, in creation of a database. So these are the learning objectives and these points are to be covered in this video. So first, we are going to learn about the role of database design, then system development lifecycle and its phases, database development lifecycle and its phases, then the processes in system development lifecycle and database development lifecycle frameworks, then different approaches to be covered in database design. So let's start with information systems. So information system, what is an information system? So it usually contains the users, hardware or software involved, and various application programs, procedures, and guidelines too. So an information system is a system that provides the conditions for data collection, storage, and retrieval, facilitates the transformation of data into information, and provides the management of both data and information. And there is another one term called system analysis. So, system analysis is a process of studying a procedure or business in order to identify its goals and purposes and create systems and procedures that will achieve them in an efficient way. Now, these are some of the performance factors involved in the information system. Next, we are moving into SDLC, or it's also called as System Development Life Cycle. So, SDLC is the acronym that is used to label a system development life cycle. The SDLC traces the history of an information system from its inception, that is, initialization, to its obsolescence. The SDLC is composed of 6 phases, and here are the phases being pointed out. They are planning, analysis, detailed system design, implementation, and maintenance. So here we are going to see the structured flow of the SDLC or system development life cycle. So these are the basic phases that I just told you about in the points. So planning, first starting with planning. So planning, actually what happens, so these are the action performed here: initial assessment and feasibility study. So what does it do actually? So in the planning phase, we verify the organization's objective, perspective, and scope of the problem, purpose, alternative solutions, and also we decide or analyze about cost benefit. Then comes the analysis after planning. So in the analysis phase, we define project goals, gathering requirements, scrutiny of existing system, diagnosing problems, recommending improvements to the system. Then next, system design, detailed system design, which involves creation of screen layouts, business rules, process diagrams, pseudocode, and documentation. And then it comes your implementation or your coding part. So by looking at the analysis and the detailed system design, we now start with implementing, coding, merging, and testing of the system to be developed. Now next, the last part is maintenance. So maintenance is actually the system. What happens here? The system is assessed or evaluated to ensure it doesn't become obsolete. So further changes can be implemented to the developed software. And one thing I want to mention here, all these phases in the SDLC, they are iterative rather than sequential process. So how, from planning you can move on sequentially to the lower phases, next phases, but you can also iterate back to any other phase of your choice wherever you want to go. Next, the DBLC, that is database lifecycle, like system development lifecycle. Talking about the whole system, here we are only um, going to deal with database, and this is our database lifecycle or DBLC. So DBLC is the acronym, is to label the database lifecycle. The DBLC traces the history of a database system, not the whole system, from its inception to its obsolescence. Since the database constitutes the core of an information system, the DBLC is concurrent to the SDLC. The DBLC is composed of 6 pages, and those pages are here. It is. The DBLC is composed of 6 pages, that is initial study, design, implementation, then testing and evaluation, operation, and then maintenance and evaluation. So, uh, here, if we want to talk about all the phases in detail, so what happens actually? If we are talking about all these phases, we should be uh, clear about the conceptual model, logical model, and physical model. So, in the previous chapters, okay, chapter 1, 2, you have seen what is a conceptual model, logical model, and physical model. The conceptual model actually deals with information gathered from business requirements. We basically develop the entities relationships model in the ERD. Then comes the logical model. So logical model of ERD, it also models information gathered from business requirements. It is more complex in comparison to conceptual models. And then our physical model, which represents the actual design blueprint of a relational database. That is the mostly the data storage. It deals with the data storage format. Next, we are going to see the database design process. Okay, so here in the database design process, that I just told you about the conceptual design, logical design, and then next our physical design. So those things are to be elaborated here in this slide. So let's see that I told you about conceptual design deals with the end user views, defining the entities, attributes, and domains as well as relationships, and then define also the data allocation strategy. Then next is the DBMS selection. What type of DBMS do you want to use for creation of the database? Then that is your next step. Then next is the logical design, in which you define tables, basically the tables, columns, relationships, constraints, the referential integrity, various types of constraints, and it also supports user to model the user requirements. Then lastly, your physical design, which is the data storage organization. So these are the basic steps here. And a transaction in context of a database is a logical unit that is independently executed for data retrieval or updates. In relational databases, database transactions must be atomic, consistent, isolated, and durable. Okay, so let me minimize a little bit. Now let's see this database life cycle. So here the DB, DBLC and SDLC, they mostly complement each other. So, like the database initial study is mostly dealing with the analysis of the database. In the same way, in the system development lifecycle, the first stage is also analysis, analyzing the user requirements. Then, where you have database design as the second stage, system development lifecycle, it does have the detailed design. One thing I need to mention, so DBLC constitutes of conceptual, logical, and physical designing, whereas SDLC emphasizes on screens, reports, and procedure. So likewise, after the design, we need implementation or the coding. Same in the same way, in DBLC you are going to implement. Next, here also it has the coding. So here in the DBLC, before coding or implementing, you need to decide what type of DBMS you are going to use. In the same way, here in the SDLC also, they need to decide which type of application or tool they are going to use for their implementation. Then lastly, your testing evaluation. Here also you have the testing evaluation. So they are basically flow in the same way in both of them, DBLC and SDLC. So SDLC traces the history of the life cycle of an information system, and DBLC traces the history or life cycle of a database system. So since we know that database serves the information system, it is not surprising that the two life cycles conform to the same basic phases. In the lastly, by the in the operation phase, after implementing everything in the DBLC, the database maintenance and evaluation is to be taken care of. And then here in the SDLC, the application program maintenance is also needed. Next comes your conceptual design that we have already discussed about. So the here the conceptual design, it's independent of database software and physical details, and describes mainly the entities, attributes, relationships in between tables or databases, and the constraints. And here there is a minimal data rule which is important, that specifies all the data defined in the data model are actually required to fit present and expected future data requirement. And this rule may be phrased as all that is needed there and all that is there is needed. That is your minimal data rule. Next, the steps in the conceptual design. First, data analysis and gathering requirements, then specifying entity relationships, and then model is verified. Lastly, you emphasize on distributed database design. So, in the okay, let's move on to this conceptual design, ER diagram building step. So, most importantly, what type of diagram you want to build? The entity relationship diagram in the conceptual design. And here you need to point out some of the steps listed in the table that take place concurrently, and some, such as the normalization process in the step 5, it can generate a demand for additional entities or attributes, thereby causing the designer to revise the ER model again. So for example, let's say you are identifying two main entities, then the designer might also identify composite bridge entity in between them that represents many to many relationship between those two main entities. It's kind of confusing. I will show you one example for this. But before that, let's be sure, make sure about all these steps that are needed for ER diagram building. So while you will also be building your entity relationship diagram, you need to follow all these steps sequentially. Let's see one ER diagram. So the composite entity that I was just talking about. So customer is one entity, video is an entity. So many customers can rent many videos. So here customer number is the primary key in customer table, and in video the video ID is the primary key. So in order to uh, identify a composite breeze entity in between these two, so it should have a many to many relationship between the two main entities. So how is it done actually? You can consider it in this way. Customer can request multiple videos. So there should be multiple instances in the rental, and multiple rentals. One video can also be rented out by multiple customers. We can represent it in this way. So there is a one to many and many to one, like this relationship in between this customer and video. And see one thing here, this rental is to be called as a composite entity, and if an entity is going to act as a composite entity in between two main entities like customer and video, so the rental composite entity should have the primary key, which is a combination of the primary key of main entity customer and the primary key of the main entity video as well. So this is how it looks like. Next, I'm going to move on to the DBMS software selection. So the DBMS software selection, the selection of the DBMS software is critical to information systems smooth operation. So consequently, the advantages and disadvantages of the proposed DBMS software should be carefully studied. To avoid false expectations, the end user must be made aware of the limitation of both DBMS and database. Although the factors affecting the purchasing decision vary from company to company, some of the most common are these: cost, DBMS feature tools, underlying data, what type of data model, portability, and hardware requirements. Next, we are going to see the logical design. So basically, how do we define the table, column, relationships, and constraints in database design? So here these are the steps that you need to follow for doing this. I'm going to go through each one of the step individually. So let's see the first step. Map the conceptual model to logical model components. So again, this step has other sub steps that we need to take care of. So in this step, the conceptual model is converted into a set of table definitions including table name, column names, primary keys, foreign keys to implement the entities and relationships specified in the logical design. So here let's see one example in this figure. Where did it go? Yeah, here 9.13. So as it says, the steps, you need to see the what are the strong entities, super type, subtype relationship, weak entity, binary relationship, and higher degree relationship. So here it has to decide which are the strong entities, employee and course are the strong entities, and here say professor is connected to the employee by the employee number. Okay, so here you just have to decide which are the strong entities. Then super type, subtype. So one thing I need to mention, the strong entities are something which are not dependent on any other entities for their own existence. So what does it mean by this? See, employee has a primary key EMP num, so it can recognize or identify each one of its records individually by its own. It doesn't need anybody's help. But Professor C, there are three attributes here: employee num, professor specialty, and professor rank. But here the professor's primary key is EMP num. It's kind of borrowing the primary key to act as a foreign key here, and that same key is able to identify all the records in the professor. So here we can say the professor is a weak entity. So whichever is a weak entity, there should be this type of sign up there with a oval shape and line. That signifies it's a weak entity. Now, like that, the course is also performing or behaving like employee. So that's why this is also a strong entity. Here, whichever entity has big emphasis or more emphasis, which should signify it by super type. Subtype is our professor as it is a weak entity. And the relationship we need to define also one to many from professor to class, then course to class is one to many. So these are the things you need to take care. Next, we are going to discuss about two steps. The step two, validate the logical model using normalization, and then validate the logical model integrity constraint. So in step two, it is possible for normalization issues. Again, what is normalization? There is another chapter about it. We'll be discussing it later. So this normalization issues is to be discovered during the process of mapping the conceptual model to logical model components. Therefore, it is appropriate at this stage to validate that all of the table definitions from the previous step conform to the appropriate normalization rules. It's a little ambiguous now, not ambiguous like confusing, we will see it later. Now validate logical model integrity constraint. So what is this? It involves conversion of attribute domains and constraints into constraint definitions that can be implemented within the DBMS to enforce those domains. Also, entity and referential integrity constraints are validated. Views may be defined to enforce security constraints. This is all about your logical design. Next, I am moving on to the physical design. So, it is the process of data storage organization and it accesses the characteristics of database by ensuring integrity, security, and performance. So, what are the things does it define? It defines data storage organization, and we need to look into how much data is to be stored in database and what is the user's frequency. Now we will define the integrity security measures, and then we define the performance measures such as how our database is going to process the data and at what time frequency. Next, here this is the important database design strategy, top down versus bottom up design sequencing. So if you see there is a conceptual model, entities are linked, and then there are multiple attributes. So from the model, you are kind of dividing everything up to the attributes. So either you can do it in top down or in bottom up way. So actually top-down design starts by identifying the data sets and then defines the data elements for each of those steps. So it involves the identification of different entity types first from the conceptual model and then definition of entities attributes. Then bottom up design, it first identifies the data elements or items, okay, all the attributes, and then groups them together in the data sets. First attributes, then entities, then the whole model. So although these two methodologies tend to be complementary, the database designers who deal with small databases with relatively few entities, attributes, and transactions, they tend to emphasize the bottom-up approach, going from bottom towards up. And database designers who deal with large complex databases usually find that primarily top-down design approach is more appropriate. That's all in database design.